Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. In this subject, the main factors are wear, friction and lubrication and corrosion. So in previous sessions, we have studied about corrosion and the types of corrosion, what are the main factors influence the corrosion we have studied. And then how to reduce the corrosion and how to prevent this corrosion. Already we have studied in the previous sessions, and some methods also we have seen. So in this session, uh, I, I will discuss about the material selection and alteration of environment in corrosion, in prevention of corrosion part. So what is the importance of this material selection to avoid the corrosion, and so what are the conditions, environment conditions required to minimize the corrosion. So that is alteration of the environment, we will study, we will see in this presentation. So the material selection is main factor in corrosion reducing methods. The material selection corrosion involves choosing materials that can withstand the corrosive environment they will be exposed to, minimizing the risk of degradation and failure. So it means that is, so the corrosion environment. So suppose if any surface is exposed to the environment, so that is maybe dry environment or wet environment. That is the corrosion degradation is depends upon the environment. So first of all, if you how to design any product, so first you concentrate on this material selection. Is it withstand the corrosion or not? We have to check it. So by doing this practice, you can eliminate or you can minimize the corrosion. So that's why the material selection factor is plays important role in this corrosion reducing methods. So some factors here we will discuss. The corrosion resistance. This is the most critical factor. The material should exhibit resistance to the specific type of corrosion anticipated in the environment. For example, for acidic environments, take stainless steel material, nickel alloys, and then certain plastics may be suitable. So these materials are suitable for acidic environment conditions only. So in case of marine environments, so the marine environments, the weather is different. So that the materials are stainless steel, aluminum alloys, and copper alloys are commonly used. So that is the material usage is depends upon the environment. So without knowing the material properties, you can't select the particular material for this particular environment. So which one is corrosive resistance? You should know before designing the any component. It may be mechanical component or electrical component, any engineering applications. The corrosion resistance material selection is very very important. For high temperature environments, so nickel based alloys and refractory metals. So refractory metals are like titanium, zirconium, maybe paper. These materials are withstand high temperature environments. So you can use these materials at a very high temperatures conditions. and furniture's example. So the nickel-based alloys and refractory metals comes under this category. So other factors are mechanical properties. So materials meet the mechanical requirement of the application, such as material properties. Already you know the strength, toughness, and fatigue resistance, creep, hardness, malleability. Okay, these ductility. These all are mechanical properties. So the corrosion resistance depends upon these mechanical properties. Next, cost considerations. This one is also one important factor. While corrosion resistance materials often come at a higher cost, it is essential to balance performance requirements with budget constraints. So sometimes what will happen? The investing in higher quality materials upfront can lead to long-term cost savings by reducing the maintenance and the replacement expenses. Suppose if you have used higher quality materials, so one-time investment, so it lead to long-term cost savings. Why? Because no need of maintenance, short-term maintenance, and the replacement expenses also will be reduced. So that's why before using this material, you should balance the performance requirements. So if you want the life of the component, have to give more budget for these materials. So while designing, you should you consider this cost consideration factor also. Next, comfortability. Consider the comfortability of materials, not only with the corrosion environment, but also with other materials they will come into contact with. So whenever two surfaces are in contact with one each other, there will be wear and friction. Some lubrication also required to avoid wear and friction, to reduce the friction. So the comfortability of materials, not only the corrosion environment weather conditions, it also should meet these other materials properties also. So avoid using dissimilar metals in contact with each other to prevent galvanic corrosion. So already we have studied the galvanizing corrosion type. So to avoid these type of to prevent the galvanic corrosion, so avoid using dissimilar metals. So same metals you have to use. So that is the comfortability factor you should consider in material selection. When wherever those two surfaces are in continuously contact with each other, there you must use this compatibility property, and according to this you have to select the materials. Next one, temperature and pressure. Ensure that the selected material can withstand the operating temperature and pressure conditions without experiencing the corrosion or mechanical failure. So here, first you before selecting the material, ensure that selected material can withstand the particular operating temperature or not. Similarly, the pressure conditions also. So by doing this, you can eliminate the corrosion, and you can avoid the mechanical failure of the component. Next, ease of fabrication and installation. So choose materials that are easy to work with and suitable for the manufacturing process involved in the construction of the component or structure. During manufacturing process, many machining processes are required. and fabrication and the welding and soldering, the machining process, lathe machining process, drilling machine, drilling operations, the facing operation, turning operations, knurling, and threading. These all are operations required while doing the manufacturing. So the during this process, the selected material easy to work with these all these process. So that's why you have to select the, the proper material according to the requirement, so that the mechanical properties are very important, the utility and hardness and strength of the materials. And then one more thing is, while selecting the material availability, suppose you have selected one material, that material available or not, the availability of the market, how to see. So ensure that the selected material is readily available in the required form and quantity. And regulatory compliance. So ensure that materials compile with the relevant industry standards and regulations governing corrosion resistance and the safety precautions. So you must check these compliance. Next one is environmental impact. So consider the environmental impact of the selected material, including factors such as recyclability and potential toxicity. And then historical performance. Refer to the past experiences and case studies to gauge the performance of materials in similar corrosion environments. So, historical performance. So, in previous environmental conditions, so take the reference to past experiences and case studies to check the corrosive properties and to check the performance of the component. By carefully considering all these factors and selecting appropriate materials, engineers can minimize the impact of corrosion and ensure the long-term reliability and safety of their designs. So, by selecting the material, you should carefully consider all these factors. So then your design will be successful. So without considering these factors, if you have designed any component, so what will happen? Finally, the component leads to fail. The next factor is altering the environment. So the alterations of the environment is required to minimize the corrosion. Altering the environment is a one strategy used to mitigate corrosion by modifying the conditions that contribute to corrosion. Here are some common techniques for altering the environment to prevent or reduce the corrosion given. So you can modify, you can change the environment to minimize the corrosion or to prevent the corrosion. So one is temperature control. The first thing is adjusting the temperature of the environment can influence the rate of corrosion. Lower temperatures can often slow down corrosion process, while higher temperatures may accelerate them. The controlling temperature can be achieved through insulation, heating, or cooling systems. The controlling temperature can be achieved through insulation, heating, or cooling systems. You can control this temperature. So at lower temperatures, the corrosion process will be less when compared to the higher temperatures. The higher temperatures may accelerate the corrosion. So according to the application and according to the depends upon the material, you can control this temperature. Similarly, humidity control. The moisture is a significant factor in many corrosion process. By controlling humidity levels, you can reduce the amount of moisture available to react with metals and cause corrosion. Dehumidifiers, decisions, and proper ventilation systems are commonly used to control humidity. So, moisture is a main factor in many corrosion process due to the wet weather. So, the surfaces will be corroded. So, whenever you control these humidity levels, you can reduce the amount of moisture available to react with the metals. Some commonly used to control humidity things are dehumidifiers and desiccants and proper ventilation systems are commonly used. Next, pH adjustment, the pH levels. The acidity or alkalinity of the environment can affect corrosion rates. The adjusting the pH value to a neutral level can help prevent acidic or alkaline corrosion. You can adjust this pH levels given 0 to 7 and 7 to 14 or pH to a neutral level can help prevent acidic or this alkalic corrosion. This can be done by adding buffering agents or chemicals to the environment. So in previous sessions, already we have studied about these buffering agents. So by adding these buffering agents and some chemicals to the environment, you can adjust this pH values. Next, chemical treatment. Adding inhibitors or passivating agents to the environment can help form protective layers on metal surfaces, reducing their susceptibility to corrosion. So these chemicals can be added directly to the environment or incorporated into coatings or paints applied to the metal surfaces. Adding inhibitors or some passivating agents, you can protect the metal surface. So susceptibility to the corrosion you can reduce. Chemicals can be added directly to the environment. Similarly, in the previous case, the previous pH adjustment, some chemicals directly you can add to the environment. Here also, in the same process, are incorporated into the coatings, some chemicals or paints. You can add some chemicals under the paints, and then you can apply the metal surfaces. By doing this type of treatment, you can reduce the corrosion. This is comes under chemical treatment. Next one is isolation. Preventing direct contact between metals and corrosive substances or electrolytes can help minimize corrosion. So you can prevent the direct contact with the metals surfaces or those which are corrosive substances or electrolyte materials, electrolyte liquids. By avoiding this contact with the contact with these metals and these electrolytes, you can reduce the corrosion. This can be achieved through proper sealing, coatings, or barriers that physically separate the metal from the corrosive environment. This method is called as isolation. So you can by using proper sealing or coatings, or you can use some barriers, physically separate the metal, the metal surface separated from the corrosive environment. So this process isolation. Next one is cathodic protection. The cathodic protection is a technique used to protect metal structures from corrosion by making them the cathode of an electrochemical cell. This can be achieved by connecting the metal to be protected to a sacrificial anode, or by applying an external electrical current. Already we have seen in cathodic protection method in corrosion methods, in corrosion testing methods, we have seen this cathodic protection. In this technique is generally used to protect the metal surfaces from corrosion. So, which surface you are going to be protect, that is the metal surface, make it as cathode by connecting the metal to the protector to a sacrificial anode, or by connecting to the external electrical current. This method is known as cathodic protection. Next one is oxygen control. The oxygen is often involved in corrosive reactions, particularly in aqueous environments. By controlling the availability of oxygen, you can reduce corrosion rates. This can be done through techniques such as purging with inert gases or using oxygen scavengers. So, by using this oxygen control method, you can reduce or minimize the corrosion. Next, surface coatings and treatments. Applying protective coatings or treatments to metal surfaces can provide an additional barrier against corrosion. So, these surface coatings and treatments is selected based on their compatibility with the environment. So, that's why in material selection, the compatibility factor is very, very important. So, based on their compatibility with the environment and their ability to withstand corrosion. So, according to depends upon these two factors, the coatings can be selected. By applying these coatings on a metal surfaces, you provide one protective layer, or additional barrier against the corrosion. So by using this method, you can reduce the friction or minimize the corrosion. So that by altering the environment in which metal components operate, engineers can reduce the likelihood and severity of corrosion, ultimately extending the lifespan of structures and equipment. So whenever reduce the corrosion severity, so definitely the component will be expanded the lifespan. It will give the component the component or machine elements will give good results. However, it's essential to carefully evaluate the specific conditions and corrosion mechanisms at a flare to determine the most effective mitigation strategies. So, by using these material selection factors, by studying material selection methods and what are the altering the environment methods, engineers can increase the lifespan of the components or the structures and reduce the corrosion. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.